Welcome back to another chemistry mole video. In this video, we're going to be looking at the oxidation of alcohols. So through this video, we're going to look at the reagents required for the reaction. We're going to look at the full oxidation of ethanol, the partial oxidation of ethanol, and we'll also look at the oxidation of a secondary alcohol as well and see what happens there. So first of all, the reagents required for the reaction. The first thing you will need to use is sodium dichromate, which has been acidified with sulfuric acid. Now you'll be able to see that you can write this in a number of different ways. So you can write out the full reagents like this, or we could write them out in the ionic form. So we can show the ions that are important for this reaction. So these are the key things that we have in there. So this is our dichromate ion, and these are our acidic protons that we've got in the reaction. Now, during the reaction, what we're going to be representing this reagent here as is the oxidizing agent, and we can represent that just in square brackets like this. So throughout the reaction, I'm going to be referring to a colour change for it. So no matter whether we're doing full oxidation or partial oxidation, this reagent, the oxidizing agent, is going to change. It's going to change from orange to green during the reaction. Now, if we look at an ionic equation for what's going on, the dichromate ions are becoming chromium 3+ ions during the reaction. So in the process, the chromium is getting reduced here as it oxidizes the alcohols. So let's balance this equation out just to show what's happening. So now we have a full balanced ionic equation for this reaction. Now the key thing here is that this reagent starts off as orange, and during the reaction it's going to change colour and it's going to produce these green chromium 3+ ions. So that explains the reason for the colour change in the reaction. Now, if you want to know more about these reactions, have a look at another video looking at balancing ionic equations. We're not going to focus on that today. What we want to know about here is the oxidation of alcohols. So the first one we're going to look at here is the full oxidation of an alcohol. Now, if we start off by looking at the conditions required for this reaction. So to do this, we are going to need to use refluxing. So we're going to heat this alcohol under reflux. In here, you'll place the alcohol and a few anti-bumping granules, which are in there to ensure that any large bubbles that form will burst and it stops it overheating and boiling too quickly. The refluxing apparatus here, what this does is as our vapours start to evaporate, they rise up through the column, and as they're getting oxidised, they will fall back down, and it gives them a chance to ensure that they're fully reacting and they fully oxidise during this reaction. So the equation for this is ethanol that we're oxidizing is being oxidized by this oxidizing agent that I mentioned earlier in the video. It's being turned into a carboxylic acid because it's fully oxidizing, and we're producing water during this reaction. So we've got the balanced equation there for what's happening. Now, as I said, we're going to get a color change here from orange to green because we're going from our chromium here, our chromate ions here, our dichromate ions, to chromium 3+ ions in the reaction. So heating under reflux is the method required to convert a primary alcohol into a carboxylic acid. The partial oxidation, to achieve partial oxidation, what we need to do is we need to ensure that as the vapours start to evaporate, we allow them to escape and prevent them from falling back down and fully oxidising to the carboxylic acid. So during this reaction, if we have ethanol here, this time we're preventing our alcohol from fully oxidizing by allowing it to escape through distillation. In this situation, you'll end up producing an aldehyde. So you produce ethanal during this reaction. So from ethanol in this reaction here, we go from ethanol to ethanoic acid through full oxidation. And with partial oxidation, we end up producing the aldehyde. Let's just write that down so we can see that really clearly. So ethanol to ethanoic acid in full oxidation when we heat under reflux. And then for partial oxidation, we go from ethanol to ethanal, the aldehyde. Now there's one more reaction to have a look at when we're talking about the oxidation of alcohols you need to be aware of, is if we have a secondary alcohol, we can only produce one product from this reaction. So if we have a look here, a secondary alcohol can only be oxidized to a ketone, we can oxidize propanol. We would heat under reflux. This time we end up producing propanal and water in our reaction. So this is a full oxidation of a secondary alcohol where we produce a ketone. So just to summarize and recap, during this whole set of reactions, we can either fully oxidize our alcohol here to a carboxylic acid. We could partially oxidize our alcohol here if we use distillation to an aldehyde. Or we can fully oxidize a secondary alcohol to a ketone. Thank you very much for watching. I hope you found that quick video helpful. Please remember to like and subscribe and make sure you share these videos.